okay, we're being asked to use integration by parts to do this integration over here. There's a variety of ways of doing it. The way I'm doing it over here, just go through it for you. I'm making a decision over here. I'll tell you what the decision is. I'm making this the u and this to be the dv. And again, this is going to be equal to, whoops, u times v minus v du. That's what we're trying to do here. So my u is equal to cosine of the natural log of x, and my dv is equal to 1 dx. Fairly easy to do. I want to point out that we're not going to put the constant integration when we integrate this. In other words, we're integrating this over here, but we're not putting the constant integration down. And that's fairly easy to do, by the way. You're going to get v equals x. Again, forgetting about the c at this point. Differentiating this is also pretty easy. It's going to be minus sine of its argument times the derivative of its argument. And the derivative of natural log is pretty easy. It's 1 over x. That's dx. And then I got to plug it in. All right? So it's going to be, again, it's going to be the uv. And the uv is fairly easy to write down. This over here. That's the u times the v. That's cosine natural log of x times x. And then it's going to be, let's see, minus, I'll just write this over here, but I'll verify that it's in the t as well, minus the v. And what's the v? The v is x. And then what do you get? Let's see, you're going to put down the du now, right? Well, that's going to be plus. And what's going to be plus? Sine ln x over x dx. Well, what's nice about that? The x disappears, all right? So, at least conditionally so. So this is where we're getting this over here, all right? Again, you're looking at it, it didn't get worse, but it didn't get better. I'm going to say it really kind of stayed the same, all right? This is going to be, you know, cosine natural log of x. The other one is sine natural log of x. So it seems like there's going to be 2 applications of integration by parts. Let's do it again. And we'll probably be a little bit better this time. So, you know, u is equal, just like I did before, this over here. Except before it was cosine, now it's sine. I got this, and this was pretty easy to do. This is easy to do. And we're going to write this down now, all right? So we're going to write over here. We're doing this integration here, all right? Let me point around what we're talking about. We're doing this integration. We got it into these 2 parts over here, right? What are those 2 parts? This part here and this part over here. And now we're using integration by parts on this part. And what's that going to give me? Let's take a look. It's going to give us, let's see, it's going to give you uv, so x times sine, natural log of x. I'm seeing that right here. Whoops. Let me go backwards on that. Seeing that. This is already there, by the way. And then I'm seeing minus the integration, right? What's that integration again? Let's take a look at it. It's going to be, let's see, it's going to be, yeah, we just did that before, right? So this thing times this thing, all right? That's going to give us cosine natural log of x. The x will disappear, dx, and that's written right over here. And what's remarkable about this is you're really kind of, you know, back in a loop. And the loop you're back in, you know, this thing over here is really the original integration. That's what you got over there. So what I did was I added it to both sides. I got this. That means on the right-hand side, the integrations have been removed. So I add a constant integration over there. And then what I do, I divide both sides by 2. And that constant that I divide by 2 is still a constant. I'm just going to call it c now. So it's our final answer right over here. Right? Are there other ways to do that by integration parts? Yeah, there is. There are, you know, you decide how you want to go about it, though. Thank you so much for paying attention.